Hello, this is Professor Gardetto coming to you from the state of Montana. I'm in a cabin right now, and I want to talk to you guys a little bit about homework number 20. I'm going to preview the assignment here, and let's see. There we go. So, homework 19, we talked about exponential functions, exponential equations. And so, what we do is when we start off these, just like they were in homework 19, they are built for you to be able to answer pretty easily without a calculator. There's part one, part two, part three. These are the first four questions. So it asks you basically three different exponential equations. 3 to what power is equal to 27? I think everybody knows that's 3. 3 times 3 times 3 is equal to 27. You have to, let's see, check our answer. We don't have to check our answer. We just do all parts at the same time. So part 2, 3 to the fourth power is equal to 81. So we put 4. If you have to use a calculator there just to multiply the 3's out, that's fine. But here's the new question here, which is going to lead us to a topic of logarithms. It says, between what two consecutive integers must the solution 3 to the x equals 51 be? Now, we know 3 to the third power is 27. Let me annotate through this. Okay, so we know 3 to the third is equal to 27. And we know 3 to the fourth is equal to 81. So if you have an equation like 3 to the x, and we talked about this in the Zoom session this morning. It's evening right now. I drove from Yellowstone Park to I'm somewhere in Montana right now. But 3 to the x equals between 27 and 81 is 51, right? So what we do is we know that the answer has to be in between 3 and 4. It's some decimal in between 3 and 4. Okay, we don't really know exactly what that decimal is yet. So all we do is we put in between 3 and 4, and we check our answer. And that's how the first four problems are going to be. Now, when you get to problem 5, it's going to be scary. Okay, it's going to be scary on problem 5. But I'm gonna lighten the load here for you guys a little bit. So you're going to see this word log. Okay, so let me write something out here. Okay, so when we see the word log, and that's short for logarithm, I want you to just think of this exponential equation for a second. We've talked about this before, but I'm going to write it down. 2 to the third equals 8. Okay, that's exponential form, and that's what you guys know. You guys know exponential form. You guys probably have heard of the word logarithm. You guys might have seen the word log in an equation, but you might have heard the word log, seen it on a calculator. But what we do is we rewrite this in logarithmic form. Okay, so on the right-hand side, this is exponential form. Okay, exponential form is different than logarithmic form. These numbers 2, 3, and 8 just go in three different places. So let me start with the base. Okay, we talked about the base, right? The base is 2. The base is 2. So the base goes right here. That's where the base goes. The 8 the 8 actually goes right here. And then we write the equation, and there's only one number we haven't chosen yet, and it's 3. So kind of like learning another language, you have to translate. We have to translate logarithmic form to exponential form. And so I teach students this thing. It's called the log loop. The log loop. Okay. Now, why do I call it the log loop? Okay. Well, it's something that helps you memorize where these numbers go. So the log loop always starts with the base. And then it's okay. That's a dog of mine that is in our cabin. Hopefully he stops barking. Shh. He stopped. Oh. All right. So we start here at the base. We go up through the 3, and then we loop around to the 8. That's called the log loop. So notice the log loop starts at the base. So the 2 is the base. It's raised to the exponent of 3, and it's equal to 8. So it's a different way of writing exponential equations. That's how problems 5 through 12 are going to go. And again, we're going to be doing a live lecture tomorrow morning at 8 a.m. Pacific Daylight Time, and I will be going over more examples. I'm just skipping to the types of problems that you're going to see. So 5 through 12 all deal with the log loop, changing a logarithmic equation to an exponential equation. Now, starting on 13, they give you a exponential equation, and they ask you to write it in log form. So this is the first thing you should write down is log. So log, short for logarithm. And we have to put the base in here, right? The base. Well, what's the base here? What's the base of this? The base is 9. Now, what do we put here? Well, we put 57 because we always want the log equal to the exponent. Logs and exponents are the same. A log is equal to an exponent. I'll say that again. A log is equal to an exponent. We're going to really drive that home tomorrow in our homework 21. We're going to talk about logs a lot more tomorrow. But to check to see if you did this right, you might want to do the log loop. Log loop, start with 9. It's raised to the x power, and it's equal to 57. That's exactly what we have here. 9 to the x power equals 57. Let me go to 21. All right, so 21 asks you to evaluate the logarithm without the use of a calculator. Well, the reason why they say this is you really can't even use a calculator. That log button on your calculator would not work in this problem. Now, I'll talk about that later towards the end of the mini video. So what we do here is we just write this out, copy it down, log base 2 of 8. That's basically how you say this. Log base 2 of 8 equals, well, it's equals in a box, right? So I'll just say x. I'll just say x. X is what this box is. As soon as we find out what x is, we know the answer. So how do we solve this? Well, we do the log loop. The log loop is the most important part of this mini video. Okay, so we take the log loop and we loop it around. Now notice when we take the log loop, we don't have to write the word log. It's 2 to the x power equals 8. Now, why would they say not to use a calculator? Well, we can do this without a calculator. 2 to what power is equal to 8? I think everybody knows that by now. X equals 3. And that's what we put down. We put 3 right here. This is going to be equal to 3. 2 to the third power equals 8. Those are going to beat the problems from 21 all the way through 27. And then the last 3 problems, 28, 29, and 30, you don't see the base. There's no base there. This base is missing. There's no base. There should be a number right there for logs. And what happens is this is so common, they call it a common log. It's kind of like the exponent 1. The exponent 1 you don't see. You never see the log base 10. You might see it on your cell phone. I talked about that in my Zoom lecture today. I talked about the log function on your cell phone. But the log base 10 is called a common log. And that's the log that's on your calculator. The log button on your calculator is a log base 10. So really, you could actually use your calculator here on this one. They say without, but everybody knows, you guys are online. We don't know whether you're using your calculators or not. But so the way to do this, same way, let me write X here. Let me imagine that base is 10. So we write 10. We raise this to the X power. And this equals, let's see, it's 100,000. 100,000. So how many times do we have to multiply 10 by itself to get 100,000? Well, let's see. 10 times 10 is 100. 10 times 10 times 10, 3 times, right? If we did 10 times 10, it's 1,000. So all we have to do is really count the zeros, right? Count the zeros. Count the zeros. How many zeros? 1, 2, 3, 4, 5. So there's 5 zeros, so the answer would be 5. The log base 10, which you don't see because it's a common log, the log base 10 of 100,000 is equal to 5. There'll be a lot more to this logarithmic stuff tomorrow morning in our Zoom session. If you guys can attend it live, it starts at 8 a.m. Otherwise, I'll record it and I'll do many more problems on a topic that sounds complicated, logarithms, but I think you guys will find them pretty easy once we get through some of these problems. All right. I will see you tomorrow morning.